Definition of differentiation. One of the two important concepts apart from integration method of finding the derivative of a function process that we find the instantaneous rate of change is in function based on one of its variables. The most common example is the rate change of displacement with respect to time and called velocity. Differentiation in mathematics process of finding the derivative or rate of change of a function in contrast to the abstract nature of the theory behind it. The practical technique at differentiation can be carried out by purely algebraic manipulations using three derivatives, four rules of operations, and a knowledge of how to manipulate functions. The other basic rule, called the chain rule, provides a way to differentiate a composite function. If fx and gx are two functions, the composite function fgx is calculated for a value of x by first evaluating gx and then evaluating the function f at this value of gx. For instance, if fx equals sin x and gx equal to x2, then fgx equal to sin x2 while gfx equal to sin x2.
Application differentiation in real life. First, business. Data is computed on a graph or a data table. Second, astronomy. Launch a rocket and to accurately take into account the orbiting velocities. Third, medical. Utilized to relate the concentration of drugs. Fourth, economy. Determine the difference and change when exposed to multiply condition. Fifth, video game. Calculate marginal cost, marginal revenue, maximum and predict maximum profit or minimum loss in specific condition.
Hi and Assalamualaikum. My name is Izzat Inshira binti Khairul Anwar. My metric number 01DKM22F1037. A. The graph of the curve with equation y equal to 3x power 3 minus 8x power 2 plus 5. Use differentiation to find expression for dy per dx. Y equal to 3x power 3 minus 8x power 2 plus 5. dy per dx equal to 9x power 2 minus 16x. Find the coordinates of any stationary points on the curve. At stationary point, dy per dx equal to 0. 9x power 2 plus 16x equal to 0. X equal to 0. When x equal to 0, y equal to 3 multiply 0 power 3 minus 8 multiply power 2 plus 5 equal to 5. When x equal to 1.78, y equal to 3 multiply 1.78 power 3 minus 8 multiply 1.78 power 2 plus 5 equal to negative 3.43. Therefore, the stationary points are coordinate 0, 5 and 1.78 negative 3.43. How many stationary points does the graph have? In this graph, 2 stationary points that have in the graph.
The graph uses equation y equal to negative 3x power 2 plus 8 x power 2 5 minus 0. The differentiation to find expression for dy over dxy equal to negative 3x power 3 plus 8x power 2 minus 5 dy over dx equal to negative 9x power 2 plus 60x. The coordinates of any stationary points at stationary point dy over dx equal to 0. Negative 9x power 2 plus 60x equal to 0. The answer is x equal to 0, x equal to 1.78.
When x equal to 0 and y equal negative 3 bracket 0 bracket power 3 plus 8 bracket 0 bracket 2 minus 5 is equal negative 5. And when x is equal to 0 and another x is equal to 1.78. So when x equal to 0 means y equal to negative 3 bracket 0 bracket power 2 plus 8 bracket 0 bracket 2 minus 5 is equal negative 5. When x is equal 1.78, so y is equal negative 3 bracket 1.78 bracket 3 plus 8 bracket 1.78 bracket 2 minus 5 is equal 3.43. The stationary point are bracket 0 and negative 5 and bracket 1.78 and 3.43. So the stationary points, the graph have 2. So to determine the x-intercept and y-intercept, so the x-intercept point is n bracket x y with y is equal to 0. So when y equal to 0, negative 3x power plus 8x power 2 minus 5 equal to 0. So x equal 2.37 and x equal negative 0.70 and x equal to 1. So the x-intercept points are bracket 2.37 and 0 and bracket negative 0.70 and 0 and the last one bracket 1 and 0. So the y-intercept point is m bracket x y with x is equal to 0. When x is equal to 0 means negative 3 bracket 0 bracket power 3 plus 8 bracket 0 bracket power 2 negative 5 is equal to negative 5. So the y-intercept point is bracket 0 and negative 5. So the nature of stationary point, d power 2y over dx power 2 is equal negative 18x plus 16 when x is equal to 0. So d power 2y over dx power 2 is equal to negative 18 bracket 0 bracket plus 16 is equal to 16. So the points bracket 0 negative 5 is minimum point. So when x is equal 1.78, so the d power y over dx power 2 is equal to negative 18 bracket 1.78 plus 16 is equal to negative 16.04. So the point is bracket 1.78 and 3.43 is maximum point.
For the summary, differentiation is a huge topic, But once you get the hang of it, solving the question can even be fun. It's okay if you can make sense of it just yet. Practice makes perfect. There are many applications of differentiation in science and engineering. We can see some of these in application of differentiation. Differentiation is also used in analysis of finance and economics. We can learn that differentiation has one important application. It is in the area of optimization, which means finding the condition for a maximum or minimum to occur. It is important in business, for example, to know cost reduction and profit increase. Besides, in engineering, for maximum strength and minimum cost.